sequence for you here, which is 4, 7, 10, and 13. And the term to term rule you can figure out is adding 3. So we are adding 3 every single time, and that's our term to term rule. What do I mean by term? Every single number in your sequence is called a term. So one term to another, and you can very easily find out the next term and the next term. Now, what happens if I ask you to find the 100th term of the sequence? That is when you have to figure out the position to term rule. It's called the position to term rule or the nth term rule. So, position to term rule. You will see this in the book, you will see this whenever you're doing position to term. What do I mean? What is the position of 4 in this sequence? It is number 1. Yeah, so it is term number 1. What about 7? It's term number 2. Then it's term number 3. Yeah, so position to the term. Is there a link between the position to the term? That is what the rule is. So the position to term. Let's see how we find out. Very easy way to go about it is to make a small table. Your table will help you convert. So this is a table I've drawn. It'll help you convert your sequence into a little organized way. So my term 1, these are my terms, and I'm going to convert the fill in the table now. So my term 1 is 4, term 2 is 7, term 3 is 10, term 4 is 13. Now, if I look at my sequence, you can see that we are going up by 3. We are adding 3. So as a rule, we are going to put the table of 3, the times table of 3 in our table here. Okay, so 3 times 1 is 3, 3 times 2, the second position, 3 times 2 is 6, 3 times the third position is 9, 3 times the fourth position is 12. So what have we done? I'm going to call the term as n, and we have just written down 3 times n. So we've written down 3n. Now is your important step where you look how it will go from 3 to 4. What is the relation between 3n and the term? What is the relation here? Can you figure out the relation? So 3 plus 1 is 4. There you go. And you can have a look at each one of the terms, and you'll see that the relation remains the same. So 9 plus 1 becomes 10, 12 plus 1 becomes 13. And now I have my nth term rule, which is 3n plus 1. You can use this, just verify it if you want to just verify it. So if I put n equal to 1, let's see, if n is 1, that's my first term. Let's see if we get a 4. So 3 times 1 plus 1. So 3 plus 1, which is 4. Yes, my first term is 4. You can check your rule that you've got. Just put in the values of 1, 2, 3 and figure out if it is correct. Now let's use this formula to find out the 100th term, okay? And how will we do that? Let's see how we will do that. So this is my rule. My 100th term means n equal to 100, where I will go ahead and put 3 times 100 plus 1, which will be 301. Okay, and similarly, you can go ahead and go through the slides and figure out how put in each value. You can figure out any value. You can use the 12th term. Your n is any value in the sequence. Okay. Similarly, I have also made another sequence here. You can see from 3 to 5 is add 2. Here I'm going to change it into a table again. I've made it into a table for the nth rule. I've put in my terms. Here you go. I've put in my terms. And then because it's increasing by 2, I'm going to put the 2 times table there. So 2 times n is 1 in this place. 2 times 4, 2 times 2, 2 times 3, and 2 times 4. So, and then we go ahead and find the relation between them. So 2 to 3, you can see they're all adding 1, and my nth term rule will be 2n plus 1. This is how you find the nth term rule for a linear sequence.